Another stamp function. They call this the stamp function, or greatest integer function, or least integer function. Depends on how they're doing it. I'm going to look at it at an f of x point of view. So if I did f of x, it looks to me from the origin that it went up 1, 2, 3. So that would be f of x plus 3. So I would be looking for a greater integer function plus 3. And it seems to be going up 1 over 1, up 1 over 1, as I find the slopes of each of those. So I'm looking for a plus 3 outside the brackets, and I don't see that anywhere. So that can't be my idea. That can't be my idea. So I'm going to try a different version of that, of the greater integer function, and that would be f of x. And let's see what happens here, which way it goes from the origin. It actually goes to the left. Now remember, if it's inside, if it goes to the left, that would be a plus 3. It goes to the left, 1, 2, 3. So that means inside the grouping, it's going to be a plus 3. So that would give me a greater integer function that had a plus 3 inside the grouping. And now I'm going to seek out and see if any of those exist in my answer choices. That there would be what a lot of people would guess, because it looks like it would go left 3, but it's actually this one. It's the opposite of what's inside the grouping. Actually, what you're looking for is what value makes that 0 inside the grouping. And negative 3, or going left 3, would make it 0. This one, they give me the graph and ask me to choose the equation again. So notice it starts at 0, 0. That means it doesn't have a plus anything or a shift inside, either left or right, plus or minus, either left or right, any number, okay? Like in this case, it would be 3 or 1/3. So it can't be that because it goes through 0, 0, so I can immediately get rid of this. That says it goes right 1/3, and notice it lands right on 0, 0, so it can't be choice C. The slope isn't up 1 over 1. The slope isn't up 1 over 1. So I'm going to test this slope. This has a slope of 3, up 3 over 1. So if I start at 0, 0, I go up 1, 2, 3 over 1. Notice it doesn't land me on the curve, on the graph. And I would go reverse the order, and no, it doesn't land me anywhere on the graph. That version there, so it can't be choice A. So let's test B. So B would be 1/3 x. And notice, if I start here and I go up 1 over 3, it lands right on the endpoint. If I reverse it lands right on the endpoint. But some people might ask, how did I get these? Well, when we graph linear functions, such as y equals 1/3 x, we go up 1 over 3 and then we connect the dots. And we never see another variation of this. And this happens with not continuous, discontinuous graphs. I can actually say the slope is up 1/3 over 1. And then notice when you look at it from that viewpoint, here you go up 1/3 over 1. Up 1/3 over 1. Up 1/3 over 1. Up 1/3 over 1. And you land on those other points. You never notice that if it's a continuous function. You don't notice that. So this would give me choice B. Distance between 2 points, I'm going to use the distance formula. And I'm going to subtract 2 quantities, and then add them to the other two, the square of the other 2 quantities, subtract them. And it's usually the x's here, x sub 2 minus x sub 1, y sub 2 minus y sub 1. So this would be my x1, my y1, my x2, my y2, y sub 2. And I'll plug those in. So 10 minus 10, well, that's going to give me 0. And then 5 minus negative 8, 5 minus negative 8. Another square root, the distance is going to equal the square root of 0 squared plus 13 squared equals the square root of 169. And that would just equal 13. Same idea for number 26. Big square root. I just make this template. So for 26, it's the same idea. This is my x sub 2. This is my x sub 1. This is my y sub 2. This is my y sub 1. X sub 1, y sub 1, x sub 2, y sub 2. Just plug and chug. So my negative 6 minus negative 6. Again, that's going to go to 0. I don't know why it just keeps doing that. It's a computer program. And then my negative 2 minus 9. So this is going to simplify a little bit to 0 squared plus negative 11 squared. If you notice, it doesn't matter if that's negative, because when I square that, it's going to give me 121. So that's going to equal the square root of 121, which equals 11. Midpoint is going to look like a big template. And some people ask me why it's over 2. And the reason is it's a midpoint. It's halfway. That's the definition of midpoint. And now all I do is I add the x's. So it's going to be 4 plus 2 on top of the x value, which is 6. Then I'm going to add the y's, which is 5 plus 1 on top of the y value, that's 6. And then when I simplify, notice I'll get a 3 and a 3. And a midpoint is a point. It's a coordinate. Same thing. I have this template. And it's a coordinate divided by 2 because it's a midpoint, which is halfway. That's why it's over 2. And I add the x values. That's going to give me 8 plus 10, which is 18. And then I add the y values, 3 plus 1, which gives me 4. And when I simplify, that's going to give me a 9 and a 2 as a coordinate. And it's going to be choice E. To subtract, I'm asked to subtract g from f. So notice f is 2x plus 1. Now I'm going to subtract the 3x minus 2. But this is a little tricky, you have to recall that I'm subtracting the entire quantity. So I have to quantify that. And that's the big error that a lot of people make. Because if you don't quantify that, you forget that you have to distribute that negative to both values. So this is going to give me 2x plus 1 minus 3x when I distribute the negative plus 2. I'm going to combine like terms, that's 2x minus 3x. That will give me negative x, and then 1 plus 2 plus 3. So obviously it can't be choice A. I think it's choice B. It looks like they just flip-flopped the 3 and the negative x. And it can't be choice C, so it must be choice B. All I'm asked to do here is add f of x and g of x. So basically I'm just going to add them. So do my arithmetic, but I love it that they stacked them up for me already. So that's going to give me f of x plus g of x. F of x plus g of x equals 6x squared. Now do recall, I don't do anything with the exponents, I just add the coefficients. So 6x squared, negative 2 minus 2 is minus 4x plus 16. And it's right there. It's going to be choice A. F plus G can be rewritten like f of x plus g of x. Find the inverse. To do the inverse, you flip-flop the x and y. So I'm going to rewrite this as x equals 5y plus 8. And then all you do is solve for the y value. So I'm going to minus 8 from both sides. That's going to give me x minus 8 equals 5y. So I have x minus 8 equals 5y. And then I divide both sides by the value in front of the y, which is 5. So 8 minus, or 5, x minus 8 over 5. X minus 8 over 5, choice B. Again, I flip-flop the x and y. And that's going to give me x equals 7y plus 9. And then I solve for the y value. Just try to isolate the variable y. So I subtract 9 from both sides. Let's see, that gives me x minus 9 equals 7y. And then I divide both sides by 7. And that leaves me with my answer. These are pretty nice. This one seems a little brief. Again, I'm going to flip-flop the x and y. That's going to give me x equals 9y. And divide both sides by 9. And that's just going to eliminate the 9's as before. That gives me y equals x over 9. So choice C. Quadratic equation. The vertex of this is going to be at 0, 2. Notice that one's at 0, 2. That one's at 0, 2. Negative in front, so it's going to be concave down. They're both concave down. Now I'm going to use 1, 3, 5, 7. The array of points should be in the form of 1, 3, 5. If it's just an x squared, there's a leading coefficient of negative 4. So I put that negative 4 out in front. And that's going to give me, it's going to go from the vertex down 4 over 1, down 12 over 1, and then down 20 over 1. So from this vertex, I should go down 4, 1, 2, 3, 4 over 1. Even though it's not on my screen, I think we can see that that will just miss that lattice point. So it's not going to be A. Let's take a look at this. They go down 1, 2, 3, 4 over 1. It's kind of like rude that it's not even on the graph, but if you have the intuition, you can see that that one's going to go through the lattice point. It's going to hit it. So it's choice B. On the vertex, really quick, y equals 7x squared minus 8. Y equals 3x squared plus 2. Just giving you a bunch of examples. Y equals negative 4x squared minus 1. Y equals 2x squared minus 11. I can find the vertices for these quickly. It's going to be 0, negative 8. It's going to be a 0, negative 1. It's going to be 0, 2. It's going to be 0, negative 11. So this vertex is going to be 0, negative 2. B. And here's why. If you look at this one, if you inspect number 36, you'll see why it's 0. Notice how this one is in what we call vertex form. So that's y equals A, parentheses x minus opposite, squared plus k, where hk is the vertex. And it's called opposite same in my class. So the vertex is going to be the opposite of negative 8. My h is going to be 8. And my k is what's outside the grouping, 4. Now, for this one up here, it was technically y equals 6, x minus 0 squared minus 2. Notice, they didn't waste the ink on the minus 0. So we had to imply that that was minus 0 in that format. So this one, number 36, the vertex is going to be 8, 4. To find the vertex of this one, I'm going to use technology. I'm going to use mode 5, 3. And then it's going to have an A, a B, and a C. And I'm going to type in the coefficients 1. Then I'm going to hit equal sign, and it's going to move over. I'm going to type in the next coefficient, negative 6. Then I'm going to hit the equal sign, and it's going to move over. I'm going to type in the last one, 9. I'm going to hit equals, and I'm going to hit equals a couple more times. And what will happen is it'll tell me what the x of 1 equals, it'll tell me what the x of 2 equals, and it'll tell me what the x val and the y val are. The last two items it tells you. Those are the ones I'm going to look for. Number 38, it gives me the vertex of 1, 1, 0. So the vertex is 1, 0. If I use the formula y equals A, parentheses, x minus h, squared plus k, and my h is 1 and my k is 0, so it's going to give me y equals A times x minus 1, squared plus 0. All I need now is the A value. And I'm going to find that by going from the vertex up to a lattice point. So I'm going to go from this vertex, and the next lattice point they actually give me is right there. See the lattice? To get from there to there, I go up 1, 2, 3, and then I go right 1. So my value for A in this case is going to be 3. So I'm going to replace that A with a 3. I don't need the plus 0, so that's going to be my equation. I need a minus and a 3 there. It can't be choice A. I have my 3, but I need a minus there. It can't be choice B. I have my minus, but I need a 3 out front. It can't be choice C. 3 out front, minus, it's choice D. And it can't be choice E. For this one, I'm going to mode 5, 3 it. And where it says A equals, B equals, and C equals, I'm going to type in the coefficient 1. I'm going to hit equals. I'm going to type in the coefficient 12. I'm going to hit equals. I'm going to type in the coefficient 37. I'm going to hit equals. When I do that, for my x sub 1, I believe I get negative 6 plus I. For my x sub 2, I believe I get negative 6 minus I. And those are the intercepts. If the intercept is I, has an I, that means there are no intercepts. So for 39, it's going to be E, no intercepts. With this quadratic function, you can mode 5, 3 it if you want. And that will give you, you type in 1 equals, negative 4 equals, and 3 equals. You hit equals a couple more times, and x sub 1 will either be negative, let me do it. I'm going to factor it. X, 3, 1, minus, x sub 1 will either be 1 or 3, and x sub 2 will either be 1 or 3, the other one. Okay? So that means my intercepts are going to be 1, 0, and 3, 0. Choice A. X cubed, we should know that x cubed looks like that. There's no plus number over here, it's actually plus 0. So since I know that end behavior is going to be down on the left, up on the right, it can't be choice C. Now, notice it has a plus 0. That means it's got to go through 0, 0. This one doesn't. It goes through 0, 2. This one touches at 0, 0. That means choice B is one of my answers. Even, odd, or neither. Odd exponent, that means it is odd. Even, odd, or neither. Odd exponent. I know that's an even number, but it's going to be odd. An even function, polynomial, would be something to the fourth plus something to the second. Since they're both even, it would be an even function. A neither function would be if you had x to the fifth, an odd exponent plus an even exponent, and that would be neither. Negative x cubed. Well, positive x cubed looks like that. Negative x cubed is going to look like that. They both have that shape, but it has a vertical shift of up 2 from 0, 0. So it can't be choice A. Notice it goes up 1, 2. It can be choice B. To do this, I'm going to set up a Punnett. And since the solution is 1, that means x minus 1 is a linear factor. Since the solution is 3, that means x minus 3 is a linear factor. Some people write it out like this and FOIL it. That's perfectly fine. I'm just using this graphical organizer. So that's going to give me x squared minus x minus 3x plus 3. When I combine my terms, it's going to render me x squared minus 4x all plus 3. And that's going to give me choice A. Now, if I wanted to, I can mode 5 3 that and test it. I would type in 1 equals, negative 4 equals, and 3 equals. And it would generate the answer 1, 3. For number 46, I'm going to set up another Punnett. And this time I'm going to multiply linear factors x minus 7 times x minus 7. And when I multiply those, that's going to give me x squared minus 7x plus 42, plus 49. I have to set up another Punnett. And I'm going to have an x minus 3 on the outside, and an x squared minus 14x plus 49 on the right, on the top. Now I'm going to multiply these. So that's going to give me x cubed. That's going to give me negative 14x squared. That's going to give me 49x. This is going to render negative 3x squared. This is going to generate 3 times 14. Is 42, x, and then 3 times 49 is going to give me negative 147. Now I'm going to combine my terms. That's going to give me x cubed. So as soon as I see that, it can't be b. I can add them all up, and notice the final term is negative 147. So it could be that one, it can't be this one. So by elimination, I have choice C. Find a polynomial with the given zeros. Again, I'm going to use a Punnett. X minus 2. X minus 2, it's going to give me x squared. Don't forget I have to do this one yet. Minus 2x, plus 4. My 6 squared Punnett is going to give me, on the top, x squared minus 4x plus 4. And then over here, x minus 6 from the linear factor of x equals 6. So when I fill in this Punnett, that's going to give me x cubed minus 4x squared plus 4x minus 6x squared plus 24x minus 24. So it ends in minus 24. It can't be A. It could either be B or C. The leading coefficient is x cubed, so it could be B, but it can't be C, so it has to be B. Pretty good method of eliminating all the ones that don't work. It says use long division. I'm actually going to use synthetic because there's no coefficient and there's no exponent, so I'm going to, in the backwards box, for synthetic, I'm going to put the opposite of minus 4, and I'm going to just put the coefficients 1, negative 6, and 8. I put a 0 there, generate my arithmetic bar. Some people put an arrow there. I put a 0. 1 plus 0 is 1, 4 times 0 is 4, 4 minus 6 is negative 2. 4 times negative 2 is negative 8. The remainder for this one just so happens to be 0. So that's going to give me, in the long run, an x minus 2. And that's my answer, no remainder. Again, synthetic, in the backwards box, I'm going to put the opposite of that, negative 2, and then I'm going to write down the coefficient 4, coefficient 1, coefficient negative 11, coefficient 6. I'm going to do the process. 4, negative 8. 14, 3, negative 2 times 3 is negative 6. Remainder equals 0, so it's going to give me 4x squared minus 7x plus 3. 4x squared minus 7x plus 3. More synthetic, backwards box. I put a 5. Now notice this one's a trick question. I have to put the 4 first because of the exponent. I have to put the negative 22 next because of the exponent. I have to put the 8 next because of the exponent. And then finally I have to put the constant 10. Put my 0 and set up the synthetic division process. 4 plus 0 is 4. 5 times 4 is 20. 20 minus 22 is negative 2. Multiply. Negative 2. Be careful. 5 times negative 2 is negative 10. Remainder equals 0. So it's going to be 4x squared minus 2x minus 2. 4x squared, 4x squared, 4x squared, minus 2x minus 2. It's choice D.